All right, so we've been looking at patterns and we've been looking at rules, right? And rules for finding patterns. Today it's a little bit different. What we're going to be doing is looking at describing graphs. And we've already talked about the Cartesian plane. That was one of our lessons that we've done before. Remember that the Cartesian plane consists of not one but two number lines, right? Where the horizontal one is the x-axis, the vertical one is the y-axis. The point where they meet in the center is called the, anybody remember? Origin. Excellent. Right. It's where they both equal 0. Remember the Cartesian plane. So we're going to be talking a little bit about some graphs. So we're going to just go through some pictures and answer questions and talk about some specific ideas that we can gain and describe just by looking at the graph. Okay? So there's really very little math that we're talking about doing here. Okay? So what we're going to do is, describing a graph is a way of talking about the patterns or relationships that we've been working with. Okay? So here you go. How can you describe a graph? So let's look at this example. Can you tell me any things you notice about the green line?
It's going up.
It's going up? Good. Sure.
Instead of starting at like the arrow.
Right, it doesn't start at the origin, does it? It starts a little higher. Mm-hmm.
It's straight.
And it's a straight line. Excellent.
It starts on 1 on the y-axis.
Right, it starts at 1 on the y-axis, right, instead of down at the origin. Excellent. So all of those are great observations and exactly the kinds of things that we're going to be looking at in this section. Okay? So, one of the things you noticed that it was a straight line, and anything that is a straight line we call linear. And so that's a vocabulary word I want you to make a note of. Linear. Anytime you see the word linear, you know that that means a straight, what? A straight line. Okay? Excellent. Okay. So look at this particular graph. They're asking what the relationship is. Well, the relationships can be determined by looking at the scale and the title of the scale. So what is the thing on the y-axis, the thing going up or down? What are you talking about?
Volume of ice cream.
In what kind of units?
Liters.
The volume of ice cream in liters. Excellent. Good. Who can tell me something about the x-axis, the bottom one?
So
Yes.
the time in hours.
The time in hours, right. Okay? So we have so much ice cream in liters and so much time in hours. And what do you notice about the line?
It's linear.
It's linear, but what is it doing?
Going down.
It's going down. So what do you think's happening here?
The ice cream.
Well, either it's melting, or what are you doing? You're eating it. It's being eaten or sold, perhaps, right? If this was an ice cream store or something. So the amount of ice cream is going down over a certain number of, what is the bottom one?
Hours.
Of number of hours, right? Okay, so we started off with 2 liters of ice cream, and after how many hours are we out of ice cream? 5. Good job. You guys are great.
Really sad we're selling it.
Very, very happy here. Yeah. Okay. And again, you already mentioned that it's linear because the line was a straight line. Good job. Okay. Look at this graph. Is that a straight line?
No.
No. So is it linear?
No.
No. So this graph is non-linear.
Why has it got a line on it when it's supposed to just have dots?
Well, no, it's just a line. It's just a line, right? Okay? But it's just non-linear. Okay? So you're going to have to choose whether they're linear or non-linear. Now, we're about to enter into the territory you're talking about. When you notice about this line is that it's a straight line, it's solid, and it goes all the way from one edge of the graph all the way to the other edge of the graph. Do you see that? So it's a solid line. It starts right here, and it goes all the way to the other edge, right? Do you see that?
Yeah.
So as far as the graph goes, the line goes. And so it continues all the way across the graph, right? And that is why it's called continuous. It's a solid line, and it continues all the way across the graph. Okay? So what if it started here and went from here like that? Is that a continuous line? No, because it doesn't. It's even though it's a solid line, it doesn't go all the way to from one edge to the other. Okay? Good deal. Yes?
So is it called a continuous line?
So it's just called continuous. It's a line and it's continuous. It's also linear, right? Good. Now look at this line. The first one, the purple line, is continuous because it's one continuous line, yeah? But look at the second one. The second one is just a line made up of a bunch of what?
Dots.
A bunch of dots. Do they touch?
No.
No. So it's just a line of dots. And that kind of graph is called discrete. So that's a word you might not have heard before, but make sure you know because you're going to have to choose if something is continuous or if something is discrete. Discrete means each individual dot has its own meaning. They're not, there's a relationship between them. They make a line, but they don't make a straight continuous line. Okay? So, here's the number of cellos in an orchestra over time. So the number of cellos that are in the orchestra. And notice that it's just a series of dots, isn't it? Okay? Now, the reason for that is, anybody know what a cello is?
Yeah.
Yeah?
You can't have like a third or a...
Exactly. You can't have part of a cello. So exactly, you can't have a third or a fourth or a half, or you can't have 2.5, right?
Well, you could,
so,
that would be good for the cello.
Yeah, well, it won't be a cello. It's not a cello anymore if you start cutting it into pieces, right? Okay? So, all right? So, can somebody give me other things that might be measured as a discrete list?
A piano.
Piano?
Some cats.
Cats? Yeah, it's difficult to cut a cat in half in parts. Hannah?
An apple.
Apples?
No, you could have half of an apple. Yeah, because you could like...
Apples are a little different though, right? Because you cut them up. Yes. Yeah, so pieces of thing, yeah, it would be not good to have pieces, body parts, yeah?
Yeah, I was going to say human.
Yeah, people, yeah? So, some things need to be discrete and not continuous because you shouldn't have parts of them, right? Okay, good. Oops. All right, so that's going into your homework. Let's see what's next. See, I told you this was a quite easy lesson. We also can remember that the lines can either go up or they can go what? Down. And when they go up or down, the amount that they go up or down is called the slope. Anybody remember what another word for slope is? Gradient. Have you heard gradient before? Gradient or slope, they mean the same thing. And so when you think about slopes, they can either be positive or they can be negative. And all you need to know is that they're positive if the line is going, what do you think? Up. They're negative if the line is going what? Down. Okay? So a positive slope is when it goes up as you're going to the right? You read them like you do in a book. And then a negative slope goes down. So, that positive and negative. So, then this one. Is this a positive or a negative slope? Negative, which means that the amount of what you have is decreasing over time. Right? This is that ice cream graph. We don't like it when the ice cream goes away, but oh well. Okay? All right. Now, a gradient or slope is used to describe how steep the line is, the graph is. So, think of a hill, right? Are all hills the same? No. Some of them are very steep and some of them are slow and gradual. Well, you can describe that using the slope or the gradient, all right? And to do that, All right? And it's easy to see. I'm just trying to figure out how much they're going to take you here. Easy to see how much they are by looking at slope as rise over run. Rise over run. Hold on just one second. Okay? Now, think of it like this. Have you ever gone upstairs before? Most of you probably have. I'm going to go with yes. Do you move your foot forward first when you're going upstairs? If you move your foot forward, you're just going to hit the next step, aren't you? What do you do first? You lift your foot and then what? Move it forward, yeah? Right? You lift your foot and move it forward. Think about it. Stand up, walk up a stair. Everybody, stand up, walk up a stair. What do? You lift your foot and then move it forward to get to land on the next step. Because if you don't do both, you don't go anywhere, do you? Okay? Good deal. So, that is the same kind of thing that we think of when we're talking about rise over run or the slope. Stairs slope, don't they? And so they slope in steps and pieces. And those pieces are known as the rise over the run. So we can count out the rise and run, which allows us to count the slope or gradient of a line. Okay? And all we have to do is just move from any 2 points on the line. Okay? So any 2 points on the line. Now, when you're being asked a specific question, you need to make sure you're using the points they want you to use. So, let me just pose a question here, okay? So, say I have 2 liters of ice cream, right? And I want to see what the slope is, okay, when I end up with 1 liter of ice cream. So I'm going from 2 liters to 1 liter, right? So 2 liters happens right here. Do you agree with that? 1 liter happens right there. Sorry, right there. Do you agree with that? Yeah. Right? It's the 1 liter line right there. Okay. So I can find how much the slope this line is changing, or the slope, simply by counting it as rise over run. But am I going upstairs this time? No. I'm going down. So in order to get from one point to the other point, I'm not going to go up. I'm going to go what? Down.
I've just got a question, because isn't it supposed to be dots because you can have like half an hour?
Well, no, because you can have any amount of ice cream, right? You can take a tiny little bit, or you can take a whole bunch. So they're measuring how much ice cream, and time can also be in tiny little increments, right?
Yeah,
So
the dot means it's not.
Dot means you can't have everything in between, right? But in time and ice cream, you can have little pieces. So we can have smaller and smaller pieces. So what I'm going to do is I'm going to count from this top dot. We're just going to call it A, just so that y'all can know what I'm talking about, to this bottom dot, which we're going to call B. Okay? And remember, you count rise first and then run. But this time my rise is not up, it's what? Down. And each line is a unit. So 1, 2, 3, 4, 5. It took 5 lines to go down, right? Okay? Do you agree with that? Then that puts us here. Now I've got to go across that way. So I went down 5. But if you look, they're counting in little pieces, aren't they? This is a bad graph for this because of the pieces. So they went down 2/10, 4/10. Do you see what's happening? Watch your scale. 2/10, 4/10, 6/10, 8/10, right? Do you agree? That's how, because remember, watch your scale. They're going down in tenths, but they're going across in what kind of units? Not whole hours, but what? Half an hour, isn't it? Yeah. So you're going to go 1/2, 2 halves, 3 halves, 4 halves, 5 halves. So do 5 halves as a decimal. What is that? Stop that. 2.5. Okay? Now, so that gives us our rise and our run. Yes?
I just have a question. So, why don't we go down to the 1? Because when we stopped it.
Oh, we stopped. I'm sorry. So it should have been 9. I mean, sorry, 0.10. Right. 10 tenths. Sorry about that. Thank you. I didn't finish for some reason. I don't know what it went. And then, okay, think back to your fractions when you first learned fractions. Do you ever leave a decimal in a fraction?
No.
You just turn the whole thing into a decimal. How could I do that? Simply take the top and divide it by the bottom. So when somebody want to do that, what's 0.10 divided by 2.5?
Divided by
0.1 divided by 2.5. Just calculator if you have one. Anybody? No?
0.5.
Is it?
0.5.
Got me. What'd you get?
0.25.
Cheating. So I get 0.4. 0.04. So 0.1 divided by 2.5 gave me 0.04. Okay. All right. So that would be the slope of the line. In other words, how much that thing is changing. Okay? So it's easy to count out how much something is changing. Now, that was a bad graph because it was really hard to read that. So you see in 1 hour, they did it in 1 hour because one is easier to use. But let's look at some others and use a different one. Okay? So look at this one. I want to do the slope, okay? And I'm just going to count it. And they see this one will be easier because notice the scale. It's all in ones, right? So I'm going to count it as rise over what? Run. Okay. So doesn't matter where you start. So what if I just put a dot here and a dot there? As long as they're at those intersections of the grid lines, we know that's a whole number, right? What if I get in the middle of a grid line? Yeah, that's a fraction, and I'm not sure if it's a half or it looks like a half, and they're harder to work with fractions. So I'm do a grid line. So I'm going to go 1, 2, 3 up. So it gives me a rise of 3. 1, 2, 3 over. And what is 3 over 3?
1.
So that means that the slope of this is 1. Now be careful of the answers. Be careful what they're asking here, though. Every time we take one step along the x-axis, we take how many steps on the y? Well, be careful, though. We reduced it, didn't we? It's 1, and what's 1 as a fraction? 1 over 1. So that means our rise is 1, and our run is what? 1. So always reduce your fraction first, and remember that you can turn anything into a fraction by putting it over a what? 1. So every time we take one step along, I'm sorry, I'm in kind of mode. Every time we take one step there, we take one step up the y-axis. Okay? Make sure you reduce the fraction before you answer the question. Good. All right. Let's see what else they do to us. The other thing that y'all noticed was the starting points. Remember, noticed that graph that we started with didn't start at 0, did it? It didn't start at the origin. It started where y is equal to 1. And that's a very important place on a graph. It's called the y-intercept. So where does this line start on the y-axis? At 1. So the y-intercept is 1. Okay? Where does this graph start on the y-axis? On 1, yeah, you're always thinking it always starts on the y-axis and then moves to the right. So it starts at 2. Excellent. Okay? Where does this one start? At 5. Okay? So a starting point is another really important point that you need for a graph. All right? So you see that all we've really done is just read information from the graphs. So if it's a straight line, what is that called? Linear. If it continues all the way from edge to edge, it's called continuous. If it's a wiggly line, it's what? Non-linear. If it's just a line of dots, it's called discrete. Discrete. Okay? And we can tell if it goes up, what kind of slope does it have? Positive. If it goes down, it's negative. And we can find the slope by counting rise over what? Run. And make sure you reduce the fraction. Good? Okay, so again,